Okay, so I'll just go through the process of which layers you need to use and what's involved with building the site model for the winery. Okay, so to build the topography for this thing, we go to mastering and site, we use the topo surface tool. It's not showing it yet? There we go. Okay, so we're using the topo surface tool. Thanks for catching that. And so inside the topo surface tool, you'll find the create from import menu and you choose select import instance. So now what Revit is waiting for you to do is to put your cursor just over any of the entities of the CAD file. And once you click it, it pops up a list of all the layers that are in this CAD file. Now we're going to start by unchecking all of the layers, and all we want are the contour layers. So I'm going to use the index, which is our major contours, our intermediate contours, and you can see there's some other contours as well. These ones here that are indefinite, those are the ones that are off the site. They're these ones down on the hill here, which you can build or not. It's no big deal whether you include them or not. I'll include them. Now there's other layers here. The DEM is for digital elevation model. That's for other stuff that's on the site. Like they took, the surveyors took 3D location points for the roads and stuff, but I'm going to ignore all that. So it's just these few layers here. So when I hit OK, it'll build up the model. Now I don't see anything at this point because my view range is such that I do not see the topo surface points. So if I go and look at the model now in 3D, I can see all of the point objects that are in this topo surface. So now I'm done. Now Revit starts by making the material of this topo surface to be dirt, basically. If you want to start off with having a green site, which might be nice for when you're rendering it, you can switch its material. And once the material comes up, you can switch it to say something like grass. So what you'll have then is a grass site, and then you can alter parts of it if you do want to show dirt in certain places. We do have roads, so you should show asphalt in those places. So here I'm just going to look for grass. So there's some grass here. So basically I'm changing the material of my site from being just plain dirt to being grass. So now you can see that it turned green. So there I just hid the AutoCAD drawing for a moment. Now, so what you'll need to do, this view, the single view that's in the model is of sea level, like way down at the bottom here where Z is equal to 0. Now, if we want to be able to look down on top of this from this sea level view so we can do our site planning work, we need to change the view range to something quite a bit higher. So here I'll make it a couple thousand feet so that I know for sure that I am going to see down on top of the model. And there we go. So now we're seeing the topo surface. So now, the next thing we do is we might put some subregions on to draw the roads around the edges here. So you can see the surveyor has provided some curves here for roads. So if you want to put a subregion up the edge here, grab your subregion tool, and then you can try picking some of the geometry that the surveyor has provided and draw out the road. Now, some of this geometry you can see is hidden. Now, the way to see it is to go to wireframe. So we can see through the topo surface, and we can see down to find the lines below. That was part of the civil design for this site. So to make a valid topo surface, remember that you have to, it's got to be a closed shape. So I'll just do a little example here and then I'll stop. So normally what you do is you work your way across the site and draw everything that you need. With your subregion sketch, it's a little bit unusually forgiving as far as Revit is concerned, because the part of the subregion sketch can actually be off the edge of the topo surface. So here, I just want to finish my sketch, but you'll see that portions of it here are off the edge of the topo surface. Here, let me go to 3D, you'll see it even more clearly there. So you can see the pink lines of the sketch. You can see in gray there the topo surface, and I'll just finish this off with one more line just to complete it here, and use the trim command to finish. So I think I've got a closed shape. So there you go. So what I would do now, this is my roadway, I'm going to switch its material from being what it is now, which is grass, and look up asphalt. So there it is there, asphalt. So now I've got black roads and I've got green grass. So you'll be able to put other patches of material on your site as you wish to indicate, maybe where some vineyards are, you can put some planting in. With regards to planting, if you want to show some shrubs for the wine or the grapes themselves, in your planting directory, you will find RPC shrubs, and I'm trying to remember which one of those most best approximates the planting. Anyways, I'm going to load this family up. So I've got those shrubs in here now. So if I go down to my planting folder, there's the shrub family I've just loaded, and there's a whole bunch here. Let me get something here for you that I will put into our BLDG 2805 share out folder. Back when they came out with these new kinds of planting, I did a rendering of every single kind of Revit tree and conifer and shrub. So if you want to know what all of these are going to look like before you render them, you can use this guide. I know what it was the lilac. So people were using the lilac shrubs because they felt like those ones looked most like a grape bush, and I think that works pretty well. So you could use the lilac as your as the plant that you want. So anyways, I will put this up in our 2805 folder here. In share out. So I'll just plunk that in there. So you guys have that as a guide. So you'll see that in the share out folder now. Okay, so then what you'll do, now that you've got your sea level view range set so that you can actually see the topo surface, you'll link the building in. And so we've got this one piece of property here that's going to be our entire site. So we'll do the property line, and the property line now I've already drawn the edges of the property with that filled region that's here. So I'm going to do the property line now, and I'll just use the pick tool so that I can pick the edges of my subregion, hit the tab key, and there's my site. So when I finish, we have here this thing right here, There it is. So it's showing the area of my site. And I've still got this filled region, which is here, which I'll just hide for a second. So there's our property line. So your next step would be to get the topography built, get the view range sorted for this plan, which is going to end up being your site plan. Now, because I'm renaming the plan here, Revit will also ask me if I want to rename the level. I don't want the level called site plan. I still want the level called sea level. So I'm going to say no. So what this means is my floor plan is called site plan, but the level itself is still called sea level. So we want that differentiation. Yeah?
Like in an actual project, right, there will be like setbacks. How would you add this?
Detail lines. So if you're drawing setbacks on your projects, you're going to do a bunch of 2D work in this view. It's called the site plan. And you will link this back into your project. So you folks know that when you bring, first of all, you're going to bring the building onto the site and place it. And then publish coordinates to the building. Then you can turn around and go inside the building and import the site. But when you import the site, go into your Revit links, which I don't have a tab for it here because I don't have anything linked into this file. Well, here, I'll give you an example later. We'll go back and talk about the, remember we had that house and the site model that we did first or second class? I'll use that as an example later. And we'll talk about how you get the view linked in. So you're going to create your site plan view here. Building's going to be linked in. Your setbacks are going to be here. Detail lines for your setbacks. Put in your dimensions for your setbacks, your dimensions for your property lines, all of that stuff. And then this view will get linked into the one for your building. Because your building, that file is going to be the one that has all your sheets. Right? So you want to take the site plan from here, link it into your file with the building in it, and put it onto a sheet. So we'll cover that a bit later. Okay, so what we're going to do now is we're going to move on to the building itself just for a moment, and then we'll get into the notes. So with regards to the building, so what we've provided here are the 3 different levels that comprise this project. So we've got our lower floor, our mezzanine, and the main floor. It's already drawn up for you. On each one of these plans, we have purple lines, which are just room separation lines, which I made thick and purple so they'd be really easy to see. This is just a guide. Now, what you can do is draw walls on those lines, or you can change the form of the building slightly or radically. You can do as much as you want with this. You're free to make whatever changes to this floor plan, but this is just sort of a working guide because in terms of how the building in real life is laid out, this is somewhat similar, maybe a little bit simplified for sake of time. But on your main floor, it makes sense to have your retail up in this top corner because that's where the entrance to the site is, and then the fermentation room's at the back, and this is at the high point at the road where the grapes were brought in and all that stuff. So the arrangement is sensible, but you certainly are welcome to change the form of the building. And if you don't like the example woodsy exterior on it, you can do whatever you want. We've had some absolutely crazy designs submitted for this winery, which don't look like any winery I've ever seen, but it was some pretty cool stuff. Have at it. That's quite cool. Again, you're welcome to submit your own alternate for this project. You don't have to use this project at all. If you've got a project that you're working on right now, either here at school or at your offices, that has phasing and design options, and maybe we can throw a little bit of the massing tool set in it for doing some of the structural modeling. That's cool. We can do that. So what you're going to do is just draw walls, on these locations, and then once you're done, take these room separation lines and delete them once you've got walls in place. These are room objects, right? So as long as you've got walls around them, they'll work. So these are designed to be placeholders here so you can put walls around them, and the room list is sort of already worked out. So let's move on to the notes here tonight. So we're talking about 3D families. Now I'm just going to stop this stream so I can put this in a separate folder from tonight's stuff. All right, so okay, so when we're building families, there's some stuff that will help you to know that will make this whole process less daunting. Now, can I get you folks to go to the File menu, hover over New, and then click Family? So what you're going to see here is a list of all of the different templates for building families that Revit provides, and it's quite a large list. There. So what's that? Probably about 70 different files, right? Now, on first blush, that looks a little intimidating. But as it turns out, there's really not as many templates as you might think. Now, I'll explain why. Look for all of the family templates that are called wall-based. Wall-based, wall-based. There's a few of them, isn't there? And you'll see that there's some that are ceiling-based and some that are roof-based. Well, folks, those are basically all the same template. They're all the same. So, for instance, I'm going to pick generic model, wall-based. You know what this thing is? It's a door. It's also a window. So when we open it up, we get a little piece of wall in here. So how is this also a door and a window? Well, when you're building families, inside the family editor, there's this button up at the top here which is called Family Category. This allows you to change the category of a family after you've been working on it for a while. So it isn't a button that you'd use very often, but there might be some times where it's a little bit blurry. You might be building something and you're not sure if it's going to be built by the furniture people or if it's going to be built by the millwork people, right? So it could be casework, it could be furniture. So here, when you go into that button, you can see right now generic models is selected. So I hit casework, hit OK, save it. It's now a casework family. So you can change it into being any other kind of category that you want. Now, usually your families don't have an identity crisis like this, but there is the odd occasion, like I said, where you have custom stuff that you're building for your project that might be furniture or it might be millwork. Now, so to get started, let me just close this down here. I'm going to go back to that same new family dialog box. So again, you have to click on File, hover over New, and then click Family. So a lot of these templates are the same thing. Now, some of them are hosted. So the ones that say ceiling-based or floor-based or roof-based, any of those that have based in their name, they are called hosted templates. So if I use the generic model wall-based template to make some kind of an object, if a wall is not present in my project where I insert this family can't exist. So a hosted template requires the host so it can be placed in your model. So you have to decide if you're going to use a hosted template or not. And I'll give you a good example. The upper cabinets in Revit's library are wall-based. So if you're trying to put your lower cabinets in, they can be freestanding. They can sit anywhere in the room. But if you want to put upper cabinets into your kitchen, there has to be a wall behind them or Revit won't let you insert them. Well, what if you want to suspend your upper cabinets from the ceiling, right? So sometimes you have that where you have a bulkhead and the mill workers are going to hang those cabinets down from the ceiling. Well, there's no wall there, so you couldn't do it. So what I have done is I've made upper cabinets that aren't wall-based. So I started, instead of casework wall-based, I just used casework. So now I have a upper cabinets that I can put wherever I want. Now the downside is if my wall moves, my cabinets don't. So the nice thing about using hosted templates is if the host moves anywhere in your design, you don't have to move these cabinets in a second pass. So there's a little bit of convenience with it, but you folks get the idea. Some of that convenience comes at a price. So when you get into this dialog box, most of you will have a pretty good idea of which one of these templates you need to use. Now predominantly you folks will probably be using mostly the window template or the door template, because those tend to be the things that we need to build most of the time. Mostly the other stuff that you want to use in your project, furniture and so on, you can get it offline and you don't have to model it yourself. Now let's look at hosted or not. So not only there's a situation of whether you want to have it hosted or not, but if you delete the host, so goes the family. So if I have those upper cabinets and they're wall hosted and I delete the wall that those cabinets are on, the cabinets go with it. Another situation, any of you who are doing multifamily work with Revit and you're using groups, sometimes you might have a tub that's in your unit plan group, and that tub is on a wall that is not in the group. Now, if that doesn't make any sense to you, just throw it away. You probably don't need to know it. But any of you who are working in multifamily work, that's a situation. So what we found is that we had to make a tub family that was not wall hosted, so we could just place it in our plan, and if there's any hiccups with the location of that demising wall or the wall that wasn't in with our unit plan, it wasn't going to be an issue. Okay, so the assumption that we're going to make here is that we're going to be working with the window family. So you can see there's the window right there, which is basically same thing as a generic model wall-based, but it's had its category changed to window. So now let's flip over to the page here. So these are all the different kinds of templates that you're likely to use at some point in the architecture realm. Some of them have asterisks on them because we don't cover them in this course, and it's unlikely that you would need to create them for yourself. Now looking at the bottom here, these are really the only different kinds of 3D families that we are going to work with, that you are going to use in Revit. So unhosted families. So that means any of these families that you see here, these templates that don't have something at the end like a ceiling based or wall based, these are free-standing families. They don't need a host. You just stick them on your floor and there they are. So generic model on its own, lighting fixture on its own, planting, plumbing fixture. These are all objects that would just float in space wherever you put them. Now, one other thing just to talk about here is your lighting fixtures. So if we were putting lighting fixtures into this wonderful room that we are in right now, there's no ceiling. So if I was trying to put these suspended light fixtures in here, there's no ceiling object on which to host them, so I couldn't put them in. Sometimes you will find ceiling objects that you get online that the creator of that family made them ceiling hosted, and then you can't use them in a room like this. So sometimes I remember a project where we had to use, there was a lighting fixture specified, went online to grab it, it was ceiling based. There was no ceiling in the room, so we had to model a ceiling and then hide it. Anyway, so those are some of these different issues. Okay, on to page 3. Now, when you think of something like a filing cabinet, tall filing cabinet, like a 5-footer, when we see it in plan, it does not appear cut like a wall. So it doesn't get, a thick line drawn where the cut plane passes through it. That's by design. So something like cabinets are specialty equipment. They are never shown cut, regardless of how high they are in plan, or even if we cut the section line right through the middle of a cabinet, it never shows cut. It always shows only in projection, and that is by design. Now if you look at that table in the middle here, there are some categories where you can decide if the plan cut plane or the section cut plane passes through those families, whether that geometry shows cut or not. So these are the different categories here. So for instance, generic models, if you use a generic model family here, so a generic model would be for something like a custom fireplace. So those would be a generic model. Or something else that's hard to categorize, like a decorative wall brace. Those will always be shown cut. No option. So that's the kind of stuff that we're talking about on page 3. So I will skip on to that. And then the next thing to talk about is the geometry inside a family. Now I just opened up the generic model family because I want to show you the dialog box in the middle of page 3 on the right hand side. Now we're going to be talking about this dialog box a fair amount tonight. So this little solid that I've created here, this is the button we're talking about. This is an important dialog box. So any geometry that you build in a family, you can tell Revit when you want it to appear. Now notice we've got coarse, medium, and fine. So what this means is that there are some geometries that you can set to hide until the level of the detail of the view becomes medium or fine. So I can have a piece of geometry that will hide itself at the coarse level of detail. So let's say you've got something like a doorknob. There's no point seeing a doorknob at 1/8 of an inch to a foot. But if you're doing a close-up rendering in it, you know, you got a rendering and you're like 5 feet away from the door and you'd like to see that doorknob, change your level of detail to medium or high, and now that doorknob could be made to appear. Look at the view-specific display. Let's think about a door leaf. Door leaves are not shown in plan, not the 3D door leaf. So when we make a door, we model the door closed. But the 3D geometry of that closed door, we don't want to see it in plan. We're going to draw 2D lines of the door open so that we can see the open door as a 2D object. So that's going to be some other geometry that we draw. So that's where this dialog box is going to come into play multiple times over the next few weeks. Okay, let's go over to page 4, the family editor. So the family editor is the environment that we are in right now. So we introduced this last week when we started to talk about in-place families. And of course you don't see the architecture tab or any of that stuff. You see very basic modeling tools. So we've got a set of solid modeling tools and we've got void forms of the same. Now, the modeling process in Revit really depends on you being organized with your reference planes. Now, we are going to be building a window tonight, so I'm going to actually just quit this file I'm working on, and I'm going to open up the window template instead. So, organized with reference planes. Reference planes are the most important organizing element of your families. Create tab, reference plane. So these reference planes will set the front, back, sides, top, and bottom of your families. So for instance, with the window, if you folks were at our intro class, we showed you how to make a window. And one of the first things that we do in plan is we draw reference planes which represent the inside face and the outside face of the window. So there's the exterior, there's the interior. So I'm going to draw just a couple of reference planes informally across the opening. One on the outside, one on the inside. Those two reference planes will define the inside and outside face of the frame. One more reference plane for the glass. So even before I've gone to model anything in 3D, I have created the reference planes in plan that sets the depth of my window within the wall, within the thickness of the wall. Then we switch to an elevation view. And I had to hit zoom extents there, ZX, because we were viewed off in space somewhere like this. I don't know why. So ZX and elevation. Now, if you guys remember the window that we did in the intro course, it had 6 lights. So 1, 2, 3, 4, 5, 6. So we needed to put in more reference planes to help us organize the division of the window. So these reference planes help us create the bones of our family. So this is the very important stuff. So we create the reference planes, bottom of page 5, and then we name them. So I'm going to go back to the plan view here. So getting organized in 3 dimensions, I am going to go back up to the top of page 5 in a minute, but I just want to talk about these principles here for a moment. So reference planes, naming them. So in plan, the first thing I'll do is I will name my reference plane. So you can see that when you click on them, you can give them a name. So here I'm going to call this exterior face of frame. And then this next one is going to be the face of the glass. Exterior face of glass. And then the one on the inside will be my, well, it doesn't need to be named, but I'll name it anyway. So interior face of frame. Now, the reason I have named them is so that I can make use of them when I do my modeling it. So here, exterior face of frame, glass, and interior face. The reason I've named them is so that I can get access to them. So when we do modeling operations, reference planes help us to, what we say, constrain geometry. Constrain means have control over it. So if I have my window frame, my dividers between my panes of glass close to these reference planes, when these reference planes get moved around, my frame will move with these reference planes. So that's why we call them a skeleton. As reference planes move around in the family, your family changes size. It stretches, it flexes. So that's why we do it. Now, the named reference planes come into play here when I'm creating an extrusion. So here I'm in an elevation view and I'm looking perpendicularly at those reference planes. So when I create an extrusion, before I draw it, I tell Revit that I want this extrusion to be placed on using the Set Work Plane tool. That's why we name it. So it'll show up in this list. So when you extrude something and you're looking perpendicularly at a reference plane, if it's named, you can use it. So now when I build this extrusion for my frame, it's living on that plane. So when I finish, I look at it in plan. Now it's extruding the wrong direction, but we'll talk about that later. And you folks have seen how that's done in the intro course. We just grab it and flip it to the other side and touch it to the other reference plane and lock it and we're good to go. So what happens now? Well, we're going to have dimensions between the outside face of the wall and this reference plane here, so that as the dimension changes where that reference plane sits, you can see my window frame stretches as well. My window frame gets deeper. Now if I want, I can keep my window frame the same depth, and I can just control the depth from the outside face of the wall at which the window frame sits. So that's why we set up these reference planes. Okay, let's take a 10-minute break. We'll just grab a coffee and then we will carry on.